Thermodynamics is a branch of science concerned with energy. It is super important to engineers, chemists, and to medical health professionals, since all life requires energy to sustain itself. In thermodynamics, energy can be either heat or work. We will focus on heat since most chemical reactions release heat. When a reaction releases heat, it is known as an exothermic process. Exo means out and thermic means heat. Combustion is an exothermic process, and we are able to warm ourselves by the fire because of this. And another example of an exothermic process is the crystallization of sodium acetate out of solution. Heat is a product in an exothermic process. Endothermic reactions require heat to occur, and heat is a reactant. The dissolving of ammonium nitrate is endothermic. This process absorbs heat from the surroundings and cools things down. Many cold packs use this process. Another endothermic process is the boiling of water. Heat is required to boil water, and we have to add quite a bit of heat, far more than is available at room temperature, to boil water. The difference between the heat of the reactants and products is known as heat of reaction. Exothermic reactions produce heat, and endothermic reactions absorb heat. While heat as energy is something we are very familiar with, randomness or disorder is not something we usually think of as a scientific concept. Usually we attribute disorder to social causes, such as our house is messy because we are spending all of our time studying chemistry. However, disorder actually is a really important scientific concept. Gases are more disordered than liquids, which are more disordered than solids, and dissolved solids are more disordered than solids. Disordered is a favored state, and the second law of thermodynamics states that the disorder of the universe is increasing, and my living room is definitely following the second law of thermodynamics. Free energy, which is symbolized by the Greek letter delta and capital G, is also known as Gibbs free energy and is a measure of both heat flow and disorder, which are the two factors that contribute to what scientists call spontaneity. In our everyday life, the word spontaneous has to do with time. But in thermodynamics, spontaneous means a reaction will occur without any side intervention, but it may not occur quickly.